Hello everyone, welcome back to the channel. Today we'll be seeing about how to write a Verilog code and test bench for a full header using Dataflow modeling and structural modeling. So let's see how we can write it. First, declare module full header a comma b comma c in comma sum comma c out. So the inputs will be a comma b comma c in. So the full header is total of three inputs a, b, and c in, and inputs, not inputs, input, output are sum and c out. But as we know that there are many intermediate results for the to get the final outputs. So we have to store them in something. So we will use a wire. So basically, wire is just a connecting between this output and this input. So as you can see that there will be many intermediate connections like the output of the XOR and the outputs of the two AND gates, which will be finally ORed with to get the final C out. So we will write I is the intermediate XOR 1 comma intermediate AND 1 comma intermediate AND 2. So this will be our three wires which are just intermediate results. So let's begin with the actual writing. So assign. So the first two will are same like half headers. So the XOR of 1 is equal to XOR of A and XOR of B. So assign sum equal to I XOR of 1 XORed with C in. So these two statements will give you the final like sum. This is the intermediate, and this intermediate output is carried as an input to the actual next XOR gate, which will give the sum. So as for the C out assign, so there will be two AND gates as shown in the figure. So the AND gate of 1 will be A ANDed with B assign AND of 2, and the second AND gates the inputs will be the I XOR 1 intermediate result of the first XOR and ANDed with C in. And the last, to get the final C out, we have to OR this. Like if any one of the value is true, there will be a C out. C out equal to I end of 1 or I end of 2. So we have to end the module. So this is our logical operation for the full header. So now let's test it using our test bench. Module PB. We can give anything the name. So we have to declare the inputs as registers A comma B comma C and outputs as wires from comma C out. In the test bench we should not declare this as it is in the module itself. So we have to just give the primary input outputs. So after that we have to call the instantiate of this module f1 A comma B comma C in comma sum comma C out. So after the initial begin $monitor. So this is the completely optional statement. You can write or you can ignore it. Monitor A equal to percentage B comma B equal to percentage B comma C in equal to percentage B comma sum equal to percentage B comma C out equal to percentage B. So this is the general syntax. Now A comma B comma C in comma A comma B comma C in comma sum comma C out. So now we have to make the dump file so that we can view the waveforms. Dump file dump.vcd. Now variables dump vars 0 comma tb. After that we have to start assigning the values. So first we will give a equal to 0, b equal to 0 and c equal to 0. So we will give a timestamp of 10. So we will copy this everything, we paste. Now we will give a c in as 1. Now we will give any one of the inputs as 1 and c in will be 0, and similarly any one of the inputs as 1. Let's keep it the same. Now we will give both the inputs as 1 and c in as 0, and similarly we will give all the inputs as 1. Now we have to end the module, that is initial begin we have to end, then end module. So you can verify the output using the table shown below or beside. We have to select the tool equals Verilog. Now let's run the code. So as you can see, the waveform is there. It might be quite difficult to understand, so we will see the monitor window. So as you can see, when all the three inputs are 0, we are getting sum 0, C out 0. If any one of them is 1, we are getting sum as 1. So as you can see here also, if any of there is 1, we have to get sum as 1. And if out of 3, if any 2 are 1, then we are getting C out as 1 and sum as 0. And if all 3 are 1, we are getting both the sum and 1, C out equal to 1. So this is how the data flow modeling works. So we will be seeing the structural modeling also. It is same, but just as I mentioned in the last video, here instead of assign statements, we directly use the the models which are already predefined or pre-written. So let's see how we can write that. So everything will remain same. Just to make it easy, the wires and all, everything remains same, just the below part will be changed. So first one will be XOR. So we have to rewrite this operation. So the intermediate sum result will be XOR of 1, and here we have to give A comma B. So this part is done, we can do it. So now again we have to write another XOR for the sum. So XOR I XOR 1 comma, okay, sorry, the first will be output and next will be inputs. I XOR of 1 comma C in. So the sum part is done. Now we have to focus on the rest of the part for C out. So this will be AND operation of intermediate AND of 1 comma A comma B. So similarly AND intermediate operation of, what you can say, I and 2 comma I XOR of 1 comma C in. So for the final one, C out, okay, C out equal to I of and 1 comma I of and 2. So let's erase this. Now let's rerun the code. So, so as you can see, we are getting the same results using this or that. So this will be more convenient. If someone wants to use this, you can use this, or you can use the Dataflow modeling. So in the next video, we will be seeing about how to write the full header using two half header modules. That's it.